Okay, problem number 8. This is a no calculator problem, so I'm going to put my calculator away. So they give us an equation and they say write down f prime of x. That means take the derivative. So to take the derivative, I am going to do it term by term. I take the exponent, I multiply it by the number in front. So 2 times negative 3/4 would give me negative 6/4 x, and subtract 1 from the exponent, so I'm just left with x. And then the x, it has an invisible exponent of 1, bring that in front, multiply by the invisible coefficient of 1, I'm left with 1. And then the exponent 1 minus 1 is 0, so I have no x's, they go away. There's my derivative. Okay, and then I could reduce that, that's negative 3/2 x plus 1. Find the equation of the normal to the curve at 2, 3. So this is going to be some sort of parabola, right, upside down, because it's sad. And when x is equal to 2, I'm going to find the normal to the curve. So the normal is going to be perpendicular to the tangent. So let's say we have a tangent like this. If we have a tangent like that, the normal would be perpendicular to it. Okay, that would be the normal. This would be the normal. So I can find the slope of the tangent by using this equation, and then I need to find its perpendicular slope to find the slope of the normal. So that's what I'm going to do. So the slope of the tangent, the m of the tangent, I'm going to find by using this formula. So I'm going to plug in my x. This is my x. I'm going to plug that in right here. So I get negative 3/2 times 2 plus 1. Okay, just plugging it in here. The 2's reduce out. I'm left with negative 3 plus 1, which is equal to negative 2. So then the slope, or the gradient of the normal, is going to be equal to the opposite reciprocal of that. So that would be positive 1/2. So my equation of my normal, I'm going to write y equals mx plus b. My m is 1/2. And I know that this point is on both the tangent and on the normal. That's that point right there. So I'm going to plug in 2 for the x and 3 for the y. So I have 3 is equal to 1/2 times 2 plus b. 1/2 of 2 is 1. Minus 1 from both sides. I'm left with b is equal to 2. So my equation is y is equal to 1/2 x plus 2. That is the equation of my normal. Okay, the normal intersects the curve of f at 2, 3, okay, and at one other point, point P. Okay, so if I were to extend this, it would intersect at another point as well. Find the x-coordinate of P. Okay, so this equation is this, and the parabola is this. So if I want to find the intersection of two equations, I set them equal to each other. So I'm going to set 1/2 x plus 2 is equal to negative 3/4 x squared plus x plus 4. And now I'm going to move everybody over to the left-hand side, because when I have solved the quadratic, I want it to equal 0. So I'm going to add 3/4 x squared to both sides. So I get positive 3/4 x squared. I'm going to minus my x here, minus x here. So 1/2 minus 1 leaves me with negative 1/2. And then I'm going to minus 4, so 2 minus 4 is negative 2. Okay, so I just rearranged this. I moved these three terms over to the left side by adding, subtracting, subtracting. And I now have that. Okay, if I want to solve this, I do not like having fractions, so I want to fraction bust this. To fraction bust it, I'm going to multiply everything, both sides of the equation, by a common denominator. The common denominator here would be 4. So I'm going to multiply everybody by 4. The 4's cancel out. I'm left with 3x squared. 4 times negative 1/2 gives me negative 2. And 4 times negative 2 is negative 8. And on the other side, 0 times 4 is still 0. Okay, now I'm going to factor this. To get 3x squared, I know it's going to have to be a 3x and an x. Now I need two numbers that multiply to give me negative 8. But when I FOIL it out, I end up with negative 2. When I distribute it all out, I end up with negative 2x. I kind of have an idea of what's going to happen because I know one of the intersections is when x is equal to 2. So to get that, I'm going to probably have x minus 2. So negative 2 times positive 4, it's going to give me negative 8. So let's see if that works. 3x times negative 2 is negative 6x plus 4x is negative 2x. Yeah, that works. So then if I solve this, I get 3x plus 4 equals 0 and x minus 2 equals 0. Solve this one, I get that point right there. Solve this one, 3x equals negative 4. Divide by 3, x is equal to negative 4/3. So the x-coordinate of P is this one right here. So P has an x-coordinate of negative 4/3. Okay, part of the graph of f is given below. Oh, isn't that nice? See, this is why this is a no calculator problem. They actually give us part of the curve. And we know that the line is this. So it says, let R be the region under the curve of f from x equals negative 1 to x equals 2. Let's see. Write down an expression for the area of R. Okay, so we don't have to use the line again. But we could actually graph this. Here's 2. And then if it has an equation, a slope of 1/2, I could go up 1 over 2. Oh, and look, see, there's that intersection. And then I could go down 1 over 2. See, I could have put my line on there. And you could see that that makes sense. Negative 4/3, more or less. Okay, so, but that's not what the next thing is asking. So I don't need to do that right now. All right. Let R be the region under the curve from x is negative 1 to x is 2. It's right there. So we want this area under the curve. Write down an expression for the area of that. Okay, so it's going to be, I'm going to integrate the parabola. So negative 3/4 x squared plus x plus 4 dx from, oops, put that in the wrong place, from negative 1 to 2. Now, down here it says calculate the area. I'm actually going to use this space. So part I was just writing down the expression. So this is R. But now I actually have to find it. So this looks pretty easy. I'm going to do the antiderivative. So add 1 to my exponent and multiply by 1/3, and I still have my negative 3/4 there. Plus add 1 to my exponent and multiply by the reciprocal, and then put an x right there. And I'm going to evaluate that, from negative 1 to 2. Okay, I can simplify this. The 3's are going to reduce out, so that's going to be negative 1/4. So I'm going to go ahead and plug in my 2's. I'm going to have negative 1/4 times 2 cubed plus 1/2, 2 squared plus 4 times 2 minus, then I'm going to do the bottom one, negative 1/4 times negative 1 cubed plus 1/2 times negative 1 squared plus 4 times negative 1. All right. Okay, let's go ahead and simplify this. 2 cubed is 8. 8 divided by 4 is 2, so that'd be negative 2. 2 squared is 4. 4 divided by 2 is positive 2. Oh, look, those are going to cancel out. 4 times 2 is 8. Okay, and so that one, these just cancel out. I'm just left with 8. Okay, over here, negative 1 cubed is still negative 1. Negative 1 times negative 1/4 is positive 1/4. Negative 1 squared is 1. 1 times 1/2 is 1/2. 4 times negative 1 is negative 4. 1/4 plus 1/2 is 3/4. So 3/4 minus 4. Okay, if I subtract those, I would get negative 3 1/4. So I'm running out of room. Negative 3 1/4. But notice that's minus. Minus a negative gives me a plus 3 1/4. So sorry, this minus this. It took me a while to figure that out. So my final answer is 8, 9, 10, 11, 11 1/4. And we're looking for area, so that would be units squared. Eek, I should have used my space better. But there's my answer, 11 1/4 units squared. Okay, the region R is revolved for 360 degrees around the x-axis. Write down an expression for the volume. Okay, so we don't actually have to find it because that would be brutal. So we did this on a previous problem, but it is in your formula packet. Here's volume, pi y squared. Y is f of x. Okay, so it's pi times our function, negative 3/4 x squared plus x plus 4 squared dx. And we're taking the region R, so we need to use the same boundaries, -1 to +2. So that's it. That's all we have to write for that part there. Find, given your answer in terms of k. Okay, so they want us to do some bizarre integral here, and I actually needed a lot more room than I gave you here. So I'm gonna put this actually up here. So this one, 1 to k of f of x. So f of x is negative 3/4 x squared plus x plus 4 dx. Okay, notice I'm not using the 2. That was because it was volume that I had that exponent there. And now I'm going to integrate it. So we integrated this before, so I know it becomes this. So this is equal to, I'm just going to copy it from up here, negative 1/4 x cubed plus 1/2 x squared plus 4x, and this time from 1 to k. So if I put in my k first, now I'm going to bring it down here. I'm going to have negative 1/4 k cubed plus 1/2 k squared plus 4 times k minus, and I'm going to put in my 1, negative 1/4 1 cubed plus 1/2 times 1 squared plus 4 times 1. If I simplify this, nothing really happens because I got all these k's, but I can write it as negative k cubed over 4 plus k squared over 2 plus 4k. And then this is all going to reduce to a single number, so let's go ahead and do that. So 1 cubed is 1, 1 times negative 1/4 is negative 1/4. 1 squared is 1, 1 times 1/2 is 1/2 plus 4. So this is 4 1/2 minus 1/4. That's going to give me 4 1/4. So this would be minus 4 1/4. So my final answer, minus 4 1/4. Here is my final answer for finding the derivative in terms of k. Finding the integral in terms of k. There it is.